All right, for our transformations today, for our map review today, we're doing transformations. So this is, again, remember types of transformations would be translations, reflections, rotations, and dilations. So for the first part, you're going to be identifying transformations that are rigid. So there will be no dilations in this because rigid means to keep the same size. And if it's a dilation, it's going to stretch or shrink. So for rigid, it's going to either just be translation, reflection, rotation. And you're going to have to be specific about which type, or by how much. So this one says go from figure S to figure T. Be sure you read which one it goes to because you might go figure T to figure S and get it wrong. It wants you to start with S and then go to T. So from S to T, what did we do? I can understand kids who might think that you rotated, but you would never just rotate from this quadrant to this. If you rotated a complete 180, it would land down here. So this one instead just simply reflected over the y-axis. So this one is going to be a reflection, and it reflected over this axis. This is our point that we reflected over, which this is the y-axis. So over the y-axis. Okay, let's look at number 2. Again, be sure you're reading. This one's going from I to J. So instead of going from this one to this one, you're going from I to J. Okay, it's definitely not a reflection. It looks like it is a rotation. I'm going to look at this flat part right here and see that it went from here and it turned and went straight up against this side. So if it turned from here to here, and it only turned one quadrant, we went from this first quadrant to this second quadrant, it only turned 90 degrees. So this is a rotation, and it turned 90 degrees, and remember you need to identify if it turned 90 degrees clockwise or counterclockwise. I guess it could have gone counterclockwise 270 degrees if we went down here, up here, and then back up to here. But I think it's easier just to say it turned backwards, which is counterclockwise. So a counterclockwise 90-degree rotation. Okay, for this one, we went from figure T to figure U. So we're going from this top one to the bottom one. It looks like the shape stayed the exact same size, so it didn't turn, it didn't flip. It looks like it just kind of slid. So if it slides, that is called a translation. So a translation is a slide, and now we need to be specific. How far did it slide? So what you need to do is pick one of these points, any point you want. I'm going to pick this one that's kind of pointing off to the left. And you follow it. How far did it go to the left and how far did it go down? And it's really hard to see. I'm so sorry this copied so light, but it looks to me like it went 1, 2 to get to this point, and then it went down 1, 2, 3. So if it goes to the left 2 and then it goes down 3, that is going to be left 2, down 3. Okay, so if you write translation, you need to be specific. How far did it go to the left or right? How far did it go down or up? If you have a rotation, name the degrees and the direction. And if you have a reflection, write what it reflected over. Okay, part 2. Part 2 is you're not going to have to move this whole shape. You're just going to have to tell me where the point would be that's X. So see how there's like a little unfilled dot? You're going to just have to say where does that land after you moved it in a certain way. For example, number 4 says up 4 units. So again, these are really hard to see the lines, but up 4 units would be 1, 2, 3, 4. I believe it would land right there. And then you're going to have to put the coordinates of X after it's landed. So if we just went straight up 4, I believe that is at -7 up 6. So you always read your X coordinate first, so -7, and then you read up to Y, which I believe is at 6. So that coordinate should be -7, 6. So again, it's where it lands after you move it up 4 units. Okay, let's look at number 5. Where is this open bubble X going to land after you reflect it over the y-axis? So again, here's the y-axis. We're going to take it and we're going to flip the whole shape over here. But instead of having to actually flip the whole shape, we really just want to know where X will land. So right now, if you know you're going to flip it over here, you just want to count how far away from this line is it, and you're going to go that same distance this direction, because it's going to flip over to the other side. So I believe it's on the -5 right here. And I think it's 1, 2, 3, 4, 5. Yes. So we're going to go 5 this direction. So we're going to go -1, -2, -3, -4, -5, which I think is right there. So that new coordinate is -5, and then down 5. So -5, -5, I think would be right for that. When you get to your Delta Math assignment, this is going to be much easier to see because you'll actually be able to see the lines better. Okay, for the last one, you are rotating it 180 degrees and telling me where that open little point B is going to land after you flip this whole shape, after you turn it 180 degrees. So again, 180, it doesn't matter which direction you go. It could be clockwise, it could be counterclockwise, but it's going to land 2 quadrants away from where it is now. I'm going to remind you of what's going to be real easy. If you get a 180, write what the coordinates are, and for a 180 degree rotation, I don't know if you remember this, but XY becomes opposite X, opposite Y. So whatever X and Y are, they're going to be the exact same, but they're both going to become opposites. So B right now looks like it's at 1, 5. So if we just make them both opposites, it's going to be -1, -5. Now I would check it. Let's see. -1, -5 is going to be there. And if you did a 180 rotation, that would be right. So it's going to land right there. So a 180, just really quick reminder, X, Y, they stay in the same order, but they become opposites. So if it's at 1, 5, it would be -1, -5. So this is your answer. Okay, let's go to part 3. Part 3 is now dilations. We haven't done dilations yet on this worksheet. So reminder, dilations are stretching and shrinking, and I want it to shrink to 1/4 of the size. So if you have the coordinates 8, -8, and you want to dilate it with a scale factor of 1/4, it's going to get smaller. So it's going to get 1/4 smaller. So what you're going to do is you're going to take each of these numbers and you're going to multiply by 1/4. And for those of you who remember, multiplying by 1/4 is the same thing as dividing by just 4. So you could take 8 divided by 4 and -8 divided by 4, but that's the same thing as multiplying by 1/4. So 8 divided by 4 is 2. -8 divided by 4 is -2. And I believe it wants it, oops, I shouldn't have written it like that. It wants it as a coordinate point. So the coordinate point is 2, -2. I should have written it like that. And again, all I did was I divided by 4, since it was shrinking it, or multiplied by 1/4, which is the same thing. You can just multiply every time by the scale factor. So number 8, we're going to multiply by the scale factor of 5. So multiply each x coordinate and y coordinate by 5. And so my new one is going to be -20, -20. You just multiply each coordinate, the x and the y, by whatever the scale factor is. Okay, number 9, dilation of 1/3. So again, you can multiply by 1/3, multiply by 1/3, or that's the same thing. Multiplying by 1/3 is the same thing as dividing by 3. So you can do either one. When you're 1/3ing something, you can multiply by 1/3 or divide by 3. I think it's easier to divide by 3, so I'm going to just divide by 3, and that would be -4, -3. Okay. Turn it over. The last section of Delta Math, the last section you're going to do is just identify a single rotation or reflection. So you're literally just going to say it's a reflection or it's a rotation. So this one, it didn't reflect. It would have had to have turned all the way up here. So this one is a rotation. This one did not turn, or this little pointy thing would be pointing a different direction. It flipped. over the y-axis. So this one is a reflection. This section should be pretty easy for everyone.